J.B.S. Haldane, at the end of a famous essay on possible worlds, wrote, "Now my own suspicion is that the universe is not only queerer than we suppose, but queerer than we can suppose. I suspect that there are more things in heaven and earth than are dreamed of or can be dreamed of in any philosophy." Haldane was one of the greatest biologists of the 20th century and certainly one of the most versatile. The late Douglas Adams, author of The Hitchhiker's Guide to the Galaxy, made a living from the strangeness of science, pushing it to the point of comedy, which in certain parts of science is the only place you can push it, I sometimes feel. The following is taken from an extempore speech in Cambridge in 1998, which I had the good fortune to attend. "The fact that we live at the bottom of a deep gravity well on the surface of a gas-covered planet going around a nuclear fireball 90 million miles away and think this to be normal is some indication of how skewed our perspective tends to be." Where other science fiction writers played on the oddness of science to arouse our sense of the mysterious, Adams used it to make us laugh. And as I said, that may be the only response other than to cry, at least where some of the paradoxes of modern physics are concerned. Quantum physics, that flagship theory of 20th century science, makes brilliantly successful predictions. Richard Feynman compared its precision, its accuracy, to predicting a distance as great as the width of North America to an accuracy of the width of one human hair. That means, that predictive success means, that quantum theory has got to be true in some sense, as true as anything we know, including the most down-to-earth common sense facts. Yet the assumptions that quantum theory needs to make in order to deliver those predictions are so mysterious that even Feynman himself was moved to remark, "If you think you understand quantum theory, you don't understand quantum theory." Quantum theory is so queer that physicists resort to one or another paradoxical interpretation of it. And resort is the right word. David Deutsch, in this splendid book, The Fabric of Reality, embraces the many worlds interpretation of quantum theory. Because the worst you can say about that is that it's preposterously wasteful. It postulates a vast and rapidly growing number of universes existing in parallel, mutually undetectable, except through the narrow porthole of quantum mechanical experiments. In some of these universes, I'm already dead. In a minority of them, I have a green beard, and so on. The biologist Lewis Wolpert believes that the queerness of modern physics is just the tip of the iceberg. All science is queer. All science, as opposed to technology, is liable to do violence to common sense. And a favorite example of his is this: every time you drink a glass of water, the odds are that you will imbibe at least one molecule that passed through the bladder of Oliver Cromwell. It's just elementary probability theory. The number of molecules per glassful is hugely greater than the number of glassfuls in the world, and than the number of bladders full in the world. So every time we have a full glass or a full bladder, we're looking at a rather high proportion of the molecules of water that exist in the world. By the way, of course, there's nothing special about Oliver Cromwell or bladders. You have just breathed in a nitrogen atom that passed through the right lung of the third iguanodon to the left of the tall cycad tree. T.H. Huxley, Darwin's bulldog, seemed to say the opposite. He said, "Science is nothing but trained and organized common sense, differing from the latter only as a veteran may differ from a raw recruit, and its methods differ from those of common sense only as far as the guardsman's cut and thrust differ from the manner in which a savage wields his club." I think there's no real contradiction. Aspects of the scientific method are organized common sense, but in the framing of hypotheses, which is a very important part of the scientific enterprise, and sometimes in their testing, the greatest scientists deploy a wildness of imagination which, in the case of an Einstein or a Heisenberg, outclasses the best science fiction. I think reveling in the absurd is something that a great scientist probably does. I'm not a physicist, and I've already trespassed dangerously into the territory of what they might see as the senior science. For the rest of the lecture, I'm going to stick to biology, especially evolution. The evolution of complex life, its very existence in a universe obeying physical laws, is wonderfully surprising, or would be but for the fact that surprise is an emotion that can exist only in a brain which is the product of that very surprising process. There is an anthropic sense, then, in which, by definition, it shouldn't be surprising, because, after all, here we are being surprised. But I'd like to think that I speak for my fellow humans in insisting, nevertheless, that it is desperately surprising. Our existence is desperately surprising. On one planet, and possibly only one planet in the entire universe, molecules which would normally make nothing more complicated than a chunk of rock have somehow managed to gather themselves together into chunks of rock-sized matter of such staggering complexity that they're capable of swimming, flying, seeing, hearing, copulating, capturing and eating other such animated chunks of complexity, capable in some cases of thinking and feeling and falling in love with yet other chunks of complex matter. We now understand essentially how the trick is done, but only since 1859. Before 1859 it would have seemed very, very odd indeed. Now it is merely very odd.